blue and green. It's not only two colors, it's also a deployment technique. RDS blue-green deployment. It's in the AWS Developers Podcast. It's right now. Good morning, good afternoon. Thank you for downloading the AWS Developer Podcast every Friday in all your good podcast application, Amazon Music, Deezer, Spotify, YouTube, without the video, Apple Podcast. It's the majority of the download these days. Thank you for subscribing so you receive the new episodes every week. Today we are going to talk about the deployment techniques for your database or some kind of deployment. We are going to enter into the details. I have the pleasure to be with Tiffany, developer advocate in my team. Hello, Tiffany.
Hi, everyone.
You're somewhere in France today, or you're traveling?
No, I'm in France, in the French Alps, actually, like enjoying the mountains. So yeah.
And on the other side of the Atlantic, we have Keyur Diwan, your principal product manager in the RDS team. Thank you for joining us. Keyur, you did that episode like 2-3 years ago already with Dave. At the time, we released RDS Blue-Green. So today it's a kind of after-sales service to repeat what is Blue-Green and how developer can take advantage of that. But maybe let's start with the basic. What is a Blue-Green deployment in general without talking about database?
Sure. We can start there. So Blue-Green deployment is more of a developer concept, app developer concept. And that's where it originated. The idea of calling it blue-green is where you have your current production setup, you want to make changes to it, so you deploy those changes in a sandbox environment, which is your green, test it out, make sure it looks good, and then you flip over, right? And your changes are now in live production system. And after going into production, if things don't work for you, you don't like it, you can always flip back to the previous environment, which is your blue. So it gives you that flexibility of quickly making changes to prod environments for an app developer. So that's at a high level what blue-green is.
That's really something that came with the cloud before, because before the cloud, I cannot afford to buy a second rack of hardware to do my blue-green on premises. So this is something that became popular like 10-15 years ago when EC2 and APIs came mainstream.
Yes, absolutely. You're spot on there. Yes, this was as cloud emerged. This is one of the innovations that happened on the developer side of things.
The flexibility of the cloud.
Yes.
But for me, blue-green, it has always been like for my middleware layer in my architecture, my application server. And I was giving AWS training classes for years when I joined AWS like 10 years ago. And we kept repeating at the time, beware, be as stateless as possible because it will allow to scale out, scale in, do blue-green deployment. So when I first read about RDS or managed database with blue-green deployment, it was like a shortcut in my mind, saying, "Hey, how can we do blue-green on something heavily stateful as a database?"
Yeah, and it was challenging and tricky, right? You're spot on, right? Databases are stateful systems, and it's very tricky. So, however, right? If you look at as things have evolved, right, with cloud and everybody, there is a growing need for even databases to kind of rise up to that level. Where you could do change management kind of activities with minimal downtime, right? And as seamless as possible, because changes to databases are disruptive in many ways. It requires you to maintain that state. You have to do a switchover, right? That results in downtime, and databases are backbone for so many applications that customers host in cloud today. And any sort of downtime is not very, very friendly for the service running on cloud. For example, like when I log into Bank of America to do a transaction, it's like, sorry, you cannot log in. It's under maintenance. That's because there's a lot of things happening behind the scenes, and one of the things they're probably updating is their databases. Uh, so
But on the other side, it's possible. I never went to Amazon.com and say, hey, sorry, we are down for maintenance between that time and that time. Come back later. We are running this site 24/7 since 20 years. So it's possible.
it's possible, and it requires a lot of heavy orchestration. So there's a lot of magic behind the scenes that everybody has to build their own custom solution if you want to get to that point. Uh, and even then, it's tricky with databases. So yes, you may not see, because maybe what Amazon.com is doing is they're making these updates at midnights, right? Or some of them would do this over the weekends when the traffic is really low, and then it's a small, short window that they look at and make that flip. Uh, so yes and no. It's doable, and some customers were doing, and that was the genesis of how even we got the idea, saying, hey, we can do this. Why can't RDS offer this as a managed option?
So what's the benefits for customer?
That's essentially what we spoke about, right? Like if I am Amazon.com, or if I am Bank of America and I'm running my databases on RDS, right? I don't want to be in the business of managing databases. That's why I'm running on a managed service like RDS. So even after running on RDS, if I have to deploy engineering resources and headcounts, right, to manage, maintain, and evolve, how do I do my change management on databases? That is painful. So the ask for the customers were like, how can you make our upgrades, our database change management, less painful or seamless as possible, such that we don't have to own this, we don't have to deploy our engineers to do the job, right? It is upon RDS, which is a managed service, to orchestrate this, right? So we save resources, and it's also a much more solid experience. And more than that, they're like, you guys are the database experts. You know the internals of databases, how they operate. You also have built a control plane, which does a lot of management of this. So you should be in a much more stronger position to build these things out, versus we building a solution around you. So this emerged as a very strong feedback, and we recognize that at Amazon we do a lot of working backwards, and when we went and spoke with our customers, this started becoming like a solid theme. No matter which customer who you spoke with, upgrades and downtime became the top and center of every conversation we were having with customers.
That's so typical from AWS. Identify customer pain points. It's undifferentiated heavy lifting, as Werner, our CTO, is saying, and we take that away from our customer, and we offer that pain point as a managed services.
I have a very developer-oriented focused question. So as I understand, so you have two environments, a blue and a green one. So one that is in production, and the other one that is the staged database. Does it mean that when you're working on the green environment, you replicate entirely RDS, like your entire database, and so you have to pay for twice the amount of resources? How does it work on the pricing side of it?
As of today, yes. I mean, what we're doing is we don't charge any premium for blue-green, right? But if you're going to spin up a green environment, what it does is it does a topological clone of your blue environment. So for example, if you have one primary or a writer instance and 3 replicas or reader nodes, right, on Aurora, when you say create a green environment, we will create the exact topology of 1 writer and 3 reader nodes on the green environment. And whatever you pay for that topology on the blue, you would pay for the green as well. So yes, there is a cost associated because you have a 2x infrastructure now. But this is a short-term window, right? This is not like a long-term throughout for months or weeks that you have to run this. You'll usually see customers spin this up, whatever upgrades they have to do. They tend to do some level of testing on the green, and you'll ballpark see about 3 days. They keep the two environments live, and then they switch over, and then the cost goes away.
I see. Okay.
Yeah, so that's the idea. That new environment, the green environment, is temporary, just the time to validate the change, validate the application. After that, we switch the traffic to the green and we delete the blue,
Yes.
and we stop paying for the blue as well. So that's the starting point. It's a cloning of your database environment, not only one database, but multiple, as you mentioned, the writers and the readers as well. How does that cloning work? Is it like a block level disk copy or more at application level?
Sure. So before we do that, right, one thing I think we should highlight is Blue-Green was primarily designed more so for the use case of major version upgrades. Of databases, right? So, for example, if you're on MySQL 5.7 and you want to go to 8.0 or Postgres 14 to Postgres 17, right? And those typically require there are many breaking changes for application at times, depending upon how you've architected your applications, right, and how you want to leverage some of the new capabilities that engine rolls out. So that was the primary use case. And if we focus on major version upgrade as a use case, the way it works is on MySQL side of the house, we use bin log replication. It's logical replication. And similarly on Postgres, if you have to do a major version upgrade, you have to use native logical replication, or at least that's how we've architected the solution, right? Postgres does have physical replication, right, where you have WAL files and you stream those, but that's primarily used for minor version upgrades. So Postgres has releases for minor versions and major versions throughout the year, but when it comes to major version upgrades, you have to use logical replication even for Postgres.
So at the beginning, when we launched 3 years ago, it was a logical replication using the native tools from MySQL or from Postgres. Did I understand correctly?
So yes. So when we launched back at reInvent in 2022, we launched only for MySQL. We did not have support for Postgres, and there's a very strong rationale behind that. But we launched for MySQL, and it used binlog, which is logical replication.
Binlog is the journal of the database, it's the journal of all the transaction, and
yes.
we replicate that.
Yes.
Okay.
Yes.
So we replicate with logical replication. It means we have, after some time, there is the same data on both databases, and any additional change on the original database, the blue database, is also replicated to the green. So the green maybe will lag a bit behind the real production database, but not too much in theory. It depends on the volume of write, I guess.
Yes, you're spot on.
But the green is probably a close to perfect copy of the blue.
Yes. We have to be careful. So we create green databases by default in read-only mode. So when you start testing, a recommendation is you do read-only testing, because there is no ability. If you start writing to your green databases, you have to be extremely careful because it can break replication.
Yeah, it's not an active.
It's not an active
cluster.
Exactly. It's not an active setup, right? It's one-way replication from blue to green, and you have to be careful in terms of how you test out your green environment.
Which makes sense. I don't want to change in my test environment to be propagated back to my production environment.
Exactly.
That's what I want. But it means I cannot test all the different use cases
Exactly.
also. So how customers are working around that?
today they have to rely on how they typically test in their dev test environment, right? So they could still spin up a new major version in their dev test environment, run the kind of test they want to run. And Blue-Green really serves more as the last mile of testing, right? Before you decide to switch changes to production.
So as a developer, I would like used to work with 3 different environments, like the dev test one and then the prod one, and yeah. And so what you're saying is that's really interesting. It means that we still have this dev test database in between, and the green one is really the last step of testing Stone before
Yes.
going into prod. Okay.
That's how I see things, right? And perspectives may vary, right? How you look at these things, but this is also, to your point, right, an evolutionary thing. If we really want to turn Blue-Green into the entire end-to-end development cycle, right? That's an evolution that needs to happen. And for that to happen, we have to look at some of the very interesting aspects in terms of like maybe able to have customers, they can come and say, hey, I want to create 3 green environments, right? Today we just clone 1, right? And what that allows is like, okay, if I have now 1 blue and 3 greens, I'm going to use the first 2 greens to do my actual testing, and I don't care if it gets corrupted, but I will learn from those, update my application, make those changes, and make sure that the second one I don't see those failures. And once I don't see in the second green environment those failures, I have the confidence, and then my 3rd green is still pristine and replicating. I can switch over to the 3rd green. But that's more of an evolutionary path. We're not there yet, but that's my vision of how we could essentially turn this into a complete life cycle from
That's
dev
really
test.
Yeah, that's really interesting. Is there an option where you can do like some sort of A/B testing where you have like 20% of your traffic that goes to one database and no?
Not today.
Okay.
But this is not a new thing either. This has been constantly being discussed. These are not easy problems to solve, I would say, because again, this is a stateful system, and traffic mirroring or even grading traffic eventually, right, will have its own challenges. There are parallel tasks that you have to run, and the time when the query gets executed will still have some nuances in terms of how it writes, when it writes, and those performance behaviors may not be always apples to apples, kind of an experience on blue and green. So there are quite a few bit of challenges there to be thought through and resolved before we get there. But I wouldn't rule out that it's not a consideration for us.
It's interesting that you talk about blue-green for testing. In my mind, I have boxes, and blue-green, for me, it's a deployment technique. So it's not really for testing. It's the way to deploy it while minimizing your downtime, because you have the second infrastructure ready. You just need, quote, we are going to talk about that later, just need to switch the traffic.
Yes, it is, and that's what we've designed it today to be, right? But Tiffany poked at something which is a part of my vision, and I've been socializing this internally, is like, how can we get there? That's our North Star. So in many ways, it's also a good validation, right? I'm not the only idiot thinking about this. So, yeah.
You said that that you and the team designed a service for major upgrades, but I read into our documentation and the blog post that Chani, my colleague, wrote at the time of the launch 2-3 years ago, that customer can also use blue-green to test or to experiment with schema change on the data model. You add a column or you remove a column to a table. How does replication works in the context of changing schemas?
Yeah. So taking a step back, right? we didn't primarily design blue-green for schema changes per
Mm-hmm.
se, right? But we did have a vision that you could use blue-green deployments for database change management, right? And those changes could be major version upgrades, minor version upgrades for database engines, right? You could also use blue-green to move to next generation of database instances. So for example, moving from Intel-based instances to Graviton-based instances, right?
That makes sense. Yeah.
Things like on the RDS open source side, which we recently launched, is being able to shrink your storage size. So those kind of changes. Schema changes are another set of changes, but those are tricky. To your point, this is based on logical replication and it's unidirectional. So yes, we do allow schema changes if customers really want to do that, and we have customers who've done that successfully. Uh, uh, but you have to be careful. Green is read only by default, so you'll
Mm-hmm.
have to turn green into read write. And once you do that, now you're at risk of invalidating your blue-green deployment if you make schema changes, which is going to break replication. So in the MySQL world, for example, if you insert a column in the middle of a table, that's going to break your replication. So if you insert that kind of a schema change, that's not going to work. So it's a shared responsibility model where customers have to be educated enough. And that's why I say some of these are not app developer. You have to know the database internals. And a DBA is in a much more better position to make these kind of changes. But however, if you insert column at the end of the table on MySQL engines, right, those are fine.
Mm-hmm.
And you can make those kind of changes and switch over, and now your new production environment has that updated schema.
So adding a column at the end of a table or adding a table,
Yeah.
obviously, but some change are not possible. Deleting a column, deleting a table, obviously, that cannot, or changing the type of a column.
Yeah. So you have to be careful. You have to be very educated about how
Mm-hmm.
replications and schema managements are tied together. And as long as you have that understanding, you can carefully make those changes and put them in your live system as a part of Blue-Green. So yeah.
Are there any guardrails before making any modification to the database? Like, let's say for in the schema, and before even being able to deploy to green, like there's going to be a message saying you cannot do this.
We don't have guardrails per se in terms of schema changes. The only guardrail we have is it's read-only. So you have to consciously go turn into a read-write, right? That's one guardrail that we have, is how I see it. But the other guardrails that we have are really a part of our switch over. So
Okay.
let's say you made a schema change, right? And it broke your replication. We will detect that and we will block switchover, right? So you will not be able to switch
Mm-hmm.
over because you made breaking changes and your blue is not replicating to green anymore.
Okay.
Yeah, you can detect that at replication levels.
Yes.
Hey, the replication is not working, and so prevent the switchover.
And that's what we do, right? So those are our guardrails that we've put in place. And those are also in many ways our differentiators, right? Self-managed blue-green versus we continue to build upon different guardrails, right, within our system, so that customers trying to make it as seamless as possible, right? That you don't have to
Yeah.
worry. If you make mistakes, it's okay. We will detect those for you and we will block switchover.
Talking about switchover, it's the perfect segue to the next segment. So our DB team, as the blue-green or developer, have tested that the application is working on the blue and the green. At some point, we need to cut over the traffic from the blue to the green, and that's the switchover operation that you were talking about. How does it work? I guess from the customer perspective, it's a click in the console, but probably not only that.
Yeah. It's switchover. I mean, we have details in our tech docs as well, but it's an educated decision, right? As to when do you want to call switchover? Primarily because this is logical replication, and as Seb, you previously pointed out, right? Depending upon the workload and the traffic, and when you call switchover, there may be a lag between your blue and green, and the green may not be completely caught up. So we want to make sure there is no data loss as a part of your blue-green switchover. So the way switchover works is, customers have the ability to specify what's my maximum tolerable downtime as a part of switchover. So if a customer is aware that, hey, I have a long-running transaction, which is going to create some replica lag, they can go specify a larger switchover if that is what they can tolerate, right? And call switchover. Now, once they call switchover, the first thing we do is we block writes on both blue and green. So this ensures there is no new data coming in. And then we flesh out everything from blue over to green. And once blue and green are in perfect sync, we do a name swap. So whatever was the name of the blue database gets assigned to the green database, and the blue gets renamed as its existing name -old. So we add to its name.
So when you say the name, it's the DNS name that the client use?
Yes.
So let me recap, just to be sure I understand. We block the write, so there is no more new data coming either to the blue or the green. We wait for the replication to flush whatever is lagging between the blue and the green. And once all data have been replicated, we switch the DNS name from the blue to the green.
Yeah, so there's a step in there in between I forgot, right? We make sure replication's caught up, but we also have our guardrails running at that time, right? And looking for things like, hey, how is the health of the green instance, right? Is replication working or broken? There are other checks and balances that we look at, especially on Postgres side of things. So if all of that looks good, then we go ahead and do a switchover.
I know there is no one single answer to my next question, but how much time it takes? And I know it depends on the volume of write, of the size of the database, and blah blah blah. But what's the rule of thumbs customer can expect?
So if you look at your systems, right, and you know that your replication lag is minimal to nil, right, between your blue and green, and that's when you orchestrate your switchover, we've seen customers being able to successfully switch over in less than a minute.
So when you said like right before switching, it's read only for all of the data that is upcoming during that very short period of time, like those 1 minute. Where is the data going? Is it buffered somewhere in a third replicated environment? Or?
We don't do anything about that as of today, right? And essentially those packets will be dropped. Unless they've created something on their application side where they can redirect and take care of it. But as of now, that writes don't come in. And for that period, that's why it's called downtime, right? So for that minute or so, you have downtime until you flip over.
Okay.
Talking from an application developer perspective, a switchover, the DNS name is changing to the new new production database. It seems easy on the paper, but at code level, it has some implication. I mean, if I have JDBC or ODBC, my TCP connection will go down. It will close from one database and I need to reopen. So it means I, as a developer, have to write my code in a way, that's best practice that we are repeating, but to retry when the connection fails and to not give up and crash with a huge Java stack trace.
Which I think is pretty standard these days, right? App developers are expected to make sure they write their code in a way where you do retries and reconnect, right? So I would be very surprised if any of the modern architecture and code.
Modern.
Yes, that's why I carefully use the word modern. Yes. Don't factor that in. I mean, there are legacy systems where you may run into these challenges. So
by the way, I'm not a huge user or developer for JDBC or DBC. I guess maybe the drivers implement that at the driver level these days, no?
They do, and the other way is also database proxies, right? Those are a good way for you to interface and make sure your connections are being held while you switch over. But that's a gap we have today. I just want to make sure I highlight that as well, right? We do not support blue-green, for example, today if you have RDS proxy front-ending the database.
Because the RDS proxy itself is not able to do the switchover. That's the reason.
It's able to. We just have to figure out when can we get to the point where. Yeah. So it's a matter of when, not can it. It's like when will we do that? And we're working. These are all our future considerations, right? As to when,
You were on this podcast with Dave almost 2 years ago. It was March 2023, episode 73. If you want to listen, the state of the art 2 years ago, a couple of things changed. You mentioned a few already. One of them is the ability to shrink the volume on the green, and so to recover some disk space and pay less.
Yes. So if we have to date back, right? As I said, we launched when I spoke with Dave. We had launched only for MySQL engines, right? So we launched support for Aurora MySQL, RDS for MySQL, and RDS for MariaDB. MariaDB in many ways is similar to MySQL.
Like MySQL.
So we launched for those three engines at reInvent. And I would say about a year later, less than a year, we launched support for Aurora Postgres and RDS Postgres. And the primary reason there was you rely on community logical replication. This is Postgres open source community and the logical replication that they build and the support. And we have to rely on that for major version upgrades using blue-green. And I would say that the community logical replication, while they're making great strides to improve, there's so much more room for improvement because you do run into a lot of limitations which are native to the community logical replications. And we had to think through how do we handle those limitations? What's going to be our customer experience? We did not want our customers to shoot themselves in the foot and have a bad experience. So we had to do a lot more due diligence in terms of building this out for Postgres engines. And that's what we did. And once we did that, then the next follow-ons that we did, which we alluded to, was things like ability to shrink storage. So for a very long period of time, if you had to scale up, for example, let's say Black Friday is coming up, right? And you want to scale up your infrastructure. And now you land up going to a bigger instance. You also increase your storage capacity. Instance, you can scale down. But storage, no, it was a one-way door. And customers kind of felt locked in and they were not very happy because that operation of scaling down storage would result in long downtime.
Yeah, the only way to scale down storage, if I remember well, is to take an entire database snapshot, create a new one with a smaller storage, and then recreate the new database. That's correct?
You can imagine, right? Now it's storage, so all your data is in there, which means you have to take the service down in order for you to be able to completely restore everything on the other side.
And that might take hours.
That can take hours or days sometimes, depending upon the size of the database. So that was extremely painful for a lot of our customers on the RDS. Aurora engines do not have this issue.
Yeah.
This was more on the RDS open source engines. And just a few months back, we recently launched support for this using blue-green, where now you don't have to wait hours, but you could orchestrate this and switch over in a minute or so.
One of the news that surprised me is the news that we now support minor version upgrade. You said we started the service with major version upgrade.
Yes.
I was assuming that minor is easier than major.
miners were always supported for MySQL engine.
Okay, it's for RDS Postgres.
So this is Postgres engines, right? So we said we now support minor version upgrade for RDS for Postgres using Blue-Green. So there is a little bit of an irony here when it comes to Postgres. Your logical replication by default is turned off. And it's a static parameter, which means if you want to use Blue-Green, you have to turn on logical replication, which is a database reboot. So a solution that's supposed to help you minimize downtime introduces downtime to use it. So kind of ironic, but but that's just the way as it stands today with the PostgreSQL community, right? It's a static parameter. And so what we wanted to do was kind of minimize that friction, at least for minor version upgrade, right? So we said we will support Blue-Green with physical replication of Postgres versus logical, right? And now you don't need to do a database reboot. Minor version upgrade anyway is like a database reboot, but sometimes customers want the control, the ability to even test in read-only mode, as I was talking about, right? And now they can do that on a minor version as well. And think of things like we just talked about shrink storage, right? If you want to do a shrink storage, you don't want an additional database reboot to be able to use shrink storage. You can use that now on Postgres with physical replication without a database reboot, right? And continue through that operation. And besides that, there's a laundry list of things that are not supported on Postgres logical replication. And
that are now possible because it's a physical replication.
Yeah, and you don't have those limitations on physical replication, right? So it makes it a lot more smoother experience for customers. If you're not doing a major version upgrade and you want to orchestrate other database changes like scale storage or shrink storage or move to a different instance size or a family, right? You can do that now on Postgres using physical replication and Blue-Green.
Got that. So it means we don't do the same type of replication between MySQL and Postgres. Postgres has the two options, physical or logical, and MySQL is logical only?
Yes.
And now I understand one of the news since 2 years that you sent me is the volumes are now fully performant at time of switchover. And I read about S3 reiterating the cache, and I think about EBS. And am I right? And if yes, maybe we should explain a bit so that everybody can catch up on what's happening there.
Yeah. So for a long time, right, and we didn't have a good solution for this until recent, is we would create, this is again strictly on RDS open source engines, not Aurora engines, right? So RDS open source engines rely on EBS. And when you create, the way Blue-Green works is we do a restore from snapshot. So there's an existing snapshot for a Blue database, right? And we restore a Green database from that snapshot. So what that means is it relies on EBS, and being able to fully restore and warm up that databases, you have to go physically access that data so that it actually shows up in your volumes. Otherwise, it's not fully loaded.
Yes, EBS volumes that are loaded from a snapshot are lazily loaded.
Yes.
So the snapshot lives on S3, and it's only when the operating system will read a block that the block will be fetched, which might cause some latency or performance degradation at the beginning, at least.
Yes, and our customers infamously call it lazy loading of S3. Right, it's a very well-known issue that we've had on RDS open source for a while, and so while customers used to live with that, it became more of a challenge in the context of Blue-Green, because now what could possibly happen is if you're not aware that this is the behavior of the green environment, and you misreading that, you could accidentally switch over to production and your green database is not warmed, which goes live, and now you're going to start seeing latencies for your queries, right? So we figured out a way where we said we can actually now take care of this. And what we do is, as soon as we create a green environment during our provisioning stage, right, as the green is created, we also make sure that the green is fully hydrated, per se, right? And that way,
I think there is an option like that from the EBS team as well. It's possible when we restore a generic EBS volume. I think there is an option now to do the same, to fully rehydrate the
I know
volume.
the EBS team is working on it. I'm not aware if that went live,
Okay.
So I wouldn't speak to that. But I'm not surprised if that happened. I mean, I know EBS teams were working on that as well. So these are a lot of improvements that since we launched Blue Green, a lot of our customers have given feedback saying, like, you have to think through these scenarios, right? Not everybody's an expert. And if we want some of our newbies or even apps guys to do this, how do you simplify? And you need to take care of some of these, they call it paper cuts.
Exactly.
Right. So that's what we've been doing. We've been incrementally driving improvements to get the experience. As I said, our North Star is get to a point where this is app developer friendly. So it's been a journey since then over the last 2 years since we launched, where we're adding support for engines, use cases, and taking care of some of these kind of scenarios.
So I have questions about rollback. Like how long after a deployment can you roll back to the previous version of the database? And also, does it mean that it stays somewhere in memory? And also, I have so many questions. How does it work?
We probably need a dedicated podcast on rollback, I would say.
Okay, you can come back.
So Blue Green today does not support rollback per se. So for example, when you switch from blue to green, you don't have the ability to switch back from green to blue. That doesn't exist today.
Because it would imply that we set up a replication in the other way around, so that we start to synchronize the old blue database from the new green.
In the intro, you talked about rollback. So that piqued my curiosity. And I was like, okay, how does this work?
Go ahead. Sir.
I might have mentioned that, yes, because in traditional infrastructure Blue-Green, not talking about database, stateless infrastructure, that's one of the advantages of Blue-Green. Okay. But the question is really interesting. How do you see things, Keyur?
Yeah, so this is, you guys are poking at all the right things here, right? So we don't have rollback today, and a lot of our customers are saying, like, why don't you have rollback? And the answer is, like, yes, we want to get to a point where this is, as I said, app developer friendly, and they could go back and forth, blue, green, blue, right? You're not able to do that today. We have workarounds for that, right? Because by default, we don't delete your blue database after switchover. But we prompt you to go delete it when you think you're ready. So it's a customer choice. And the primary reason being is we want them to have a previous target that they can go back to should they have to, right? So it's a manual rollback in many ways, a choice that customers have today. But we want to orchestrate a blue-green automated rollback as well. But that is tricky. This is a stateful system. And more so, none of the engines, these are open source engines, support down version replication. So there is no formal support for replicating from a Postgres 17 to a Postgres 13. And it can break. So it has a lot of challenges that we have to think through for example, you could have a whole new way of managing your schemas on 17, but that format or those kind of capabilities are not supported on 13. And now you took traffic and wrote
Mm.
things in your databases on that version 17. How do we roll that back? It's
Yeah.
going to break. Uh, so there are multiple such scenarios that we have to think through in order to be able to have a rollback solution. I'm not ruling it out. I'm just saying it's complex.
Yeah.
Very similar to how we had complexities for Postgres engines at the beginning, and we figured up a path forward to navigate through things like DDLs are not replicated, sequences don't get synced, and how do you manage those things? Um, so yes, these are there's a lot of other lot of streams or swim lanes within blue-green that we need to go after and see how we can get to that North Star. Rollback is
Yeah.
definitely one of those.
You talk about giving the best developer experience, including for people that are not specialists of databases. You mentioned newbies or people that just write code.
Yeah.
That's one of the theme for the future of RDS Blue Greens. But how do you see the future of in general? I know we are not disclosing about specific feature and roadmap, but there are certainly trends that you can identify.
I think, as I said, the emerging trends here are really more of make blue-green more robust, right? That's the trend, is things like how do we make that better? There are things we can do on the Aurora side of things because it has more flexibility. It's our version of Postgres. But for RDS Postgres, it's community bits. So some of the trends here are we are partnering with the community to drive improvements on logical replication. And that is going to...
This means contributing back to the open source
Yes.
project upstream.
Yes, exactly. Okay. Right?
That's super important for communities.
And we are one of the top contributors when it comes to PostgreSQL community, right? And we continue to do that on a regular cadence. We have a dedicated team here that works towards that, and we give them our perspectives, saying, hey, this is an area which the community needs to evolve, and then they take it to the community and whatever the community decides at that point in time. But one of the trends that we continue to hear is make Postgres blue-green better, more rock solid, and this is in regards to logical replication. So we hear that as a constant theme. The other is minimize our downtime. It used to take us hours, sometimes days. You brought it down to single-digit minutes. That's great. We want it in seconds. Or even a network blip per se, right?
Mm-hmm.
How can you get us to that point, right? So that's the other trend that is emerging, and then
again, it depends of the replication strategy and technology.
Yeah, so I think the backbone of blue-green is really having a strong foundational replication technology that can support these things, and that will make it more seamless. And once we have built that foundation, I think the orchestration of the other part becomes a lot more simpler. Going back to rollback as well, right? The reason why rollback is challenged is, again, the foundational replication technology has a lot of barriers for us to overcome. And once we're able to do that, think of this way. If there were no replication issues, we could easily support rollback, and then the switchovers, right, could also just go back and forth, and then that's where you're closer to that CI/CD model for an app developer.
Keyur Diwan, your principal product manager in the RDS team, focusing on blue-green and I guess maybe other things as well. Thank you for explaining to the listeners of the AWS Developer Podcast so clearly the challenges and the reason and the benefits of blue-green replication at database level. Tiffany, thank you for being here. Thank you for having listened this episode until the end. Next week we are going to talk about AWS SDK for Panda, the glue, the Python glue between the Panda world and AWS services, all the data analytics services like S3, like Athena, like Redshift. That's next week, Friday, in your podcast application. But now, go build.